Do you know how electrical impulses are transmitted across the body? The simple answer is action potentials. Let's go. So first and foremost, you have something called an axon in your body. The outside of the axon membrane is extremely positively charged and the inside is negatively charged, and it's maintained at a resting potential of negative 70 millivolts. Why is this so? There is a sodium-potassium pump, which is a type of carrier protein that actively transports 2 potassium ions into the axon and 3 sodium ions out of the axon. There is now a high concentration of potassium ions inside the axon. They move via facilitated diffusion out of the axon, hence out of the axon it's positively charged, and inside the axon it's negatively charged, since both potassium and sodium ions are positively charged, but the membrane is more permeable to potassium. Okay, we've got that out of the way. Right, so what happens when you see a stimulus? Okay, you see a lion running towards you. Oh no. Right, essentially what happens is that this causes depolarization to occur if a threshold of negative 55 millivolts is reached. So sodium ion channels open, this causes an influx of sodium ions into the axon, okay, and if it reaches a threshold, more sodium ion channels open through a concept called positive feedback. Eventually it reaches 40 millivolts, and once it reaches 40 millivolts, this causes sodium ion channels to close and potassium ion channels to open. Potassium ion channels open, and this causes potassium ions to leave the axon, and essentially this causes it to become more negative. Potassium ion channels are slow to close, hence there's a short overshoot temporarily through hyperpolarization, in which the axon becomes far too negative, okay, and then eventually the sodium potassium pump restores it back to the resting potential, okay. When sodium ion channels close, essentially the refractory period starts. This is when another action potential cannot be stimulated. This is important because it ensures that action potentials are discrete impulses. You don't have too many of them, because if you had too many action potentials, this would overwhelm the senses, okay? And it ensures unidirectionality of action potential flow, so they go in one direction. Now, some drugs, some anesthetics, what they do is they block the sodium ion channels, so essentially no action potentials are stimulated. Some drugs also stimulate potassium ion channels to open. This provides an inhibitory effect, since if you think about it, if more potassium ion channels open, okay, so that means that the membrane will become far too negative, so you'll need a really strong stimulus to cause depolarization to occur. And essentially these are two ways in which you can limit the production and generation of action potentials. Thank you for watching.